equation notation into regular y equals f of x function notation. So the way to do that is called eliminating the parameter. So I want to take a quick look at that right now. So for example, suppose we have this, so let's look at the first example. X equals t plus 3 and y equals t cubed. So you want to eliminate the parameter. So the first thing you have, so you're going to solve for t. So the first thing you have two equations. You have to pick which one you want to solve for t. Now you could do either one, but the equation for x is linear, so it probably makes more sense to do it there. So you just very simply get t equals x minus 3. So now you can just plug that into the equation for y. So now you get y equals x minus 3 cubed. So using this, we've actually converted from parametric equation into regular y equals f of x notation. Or a regular x and y equation with no t. Okay. Similarly, we can eliminate the parameter for this next one. X equals 3 plus 2e to the t, and then y equals 5e to the 2t. Now, obviously, this one's a little bit harder. You can't just subtract 3 and get t by itself. So the key thing to realize here is that we're going to use, so this equation is a little trickier, but we're going to make an observation that's going to make our life easier as we convert this. So notice that both the equation for x and the equation for y, you never have t by itself. The only thing you have is e to the t. So you don't actually have to solve for t. You can just solve for e to the t, because the only thing you ever really need to replace is e to the t. So this is one little trick you might encounter when you try to eliminate the parameter. So we can solve for e to the t, and that's linear. That's very easy. In the first equation, you just subtract 3 and then divide by 2. So you get e to the t equals x minus 3 over 2. And now we're going to realize that e to the 2t is just e to the t squared. That's just algebra. So now, y equals 5, it's e to the t squared, so y equals 5, x minus 3 over 2 squared. So those are two nice examples, one simple, one a little more complicated, about how you can eliminate the parameter. So one other comment. Now it's possible to eliminate the parameter and come up with something where it's not a function. For example, if you have x equals cos t and y equals sine t, once you know that that's a circle, you can say, oh, I know the equation for this. The equation is, x squared plus y squared equals r squared or something like that. So in this case, it would be x squared plus y squared equals 1. But notice that there's no sort of like obvious way or general rule to quote unquote solve for something. In that case, in that situation, you have to go on a case-by-case basis and say, oh, I know a trig identity involving sine and cosine. So you kind of have to make it up as you go, in a sense. Okay. So that's another way to eliminate a parameter, but that one obviously is much harder because you have to go on a case-by-case basis and not just quote-unquote solve for t.
You couldn't solve like